Today's talk is about trends driving the digitization of construction. As I'm sure many of you know, construction is an age-old industry. It goes back into almost prehistoric times. And over the years, construction has fragmented into multiple specialties in the same way that other industries like mobile phones and automobiles have. But it's particularly pronounced in this industry. And the argument that I'll be presenting here is, first of all, the industry is likely to remain fragmented. There will be some attempts to integrate it, but historically these have not been successful. Secondly, this lack of integration, this fragmentation of the industry, has created significant barriers for innovation and significant barriers to improving productivity, so that productivity has essentially stagnated in this industry for the last 50 years. I believe we're on the cusp of a major transformation of the industry. So let's first of all talk about why the industry is so fragmented. A typical complex office building or hotel, even more so a hospital, a data center, may have as many as 200 separate contractors. You look at a hospital or university lab building, it could be more than 200 contractors. Why is it so fragmented? Economic theory says that an industry like this should be very integrated. My colleague at University of California, Berkeley, Oliver Williamson, has argued that in an industry where you have a lot of customization, right down to one-off versions of a product, you have a lot of uncertainty from weather, from labor availability, from global supply chains and so on, and you're not able to repeat this and learn from it. This kind of industry he calls highly asset-specific and uncertain, and it should be delivered by an integrated firm. The transaction cost of doing it any other way, he argues, is way too high. So given this theory, which won him the Nobel Prize, why is this industry still so fragmented? So construction projects are, compared to cars, even certainly compared to mobile phones, compared to toasters, the purchase of construction is usually a significant purchase for the buyer, whether it's an individual buying a single-family home, whether it's a church or a mosque or a synagogue buying a new house of worship, whether it's a university building a new building. For all of these people, it's a significant capital outlay. As a result, it's hypersensitive to economic demand in the overall economy and economic optimism about the future. These products are also large, built in place, and even the so-called mobile homes typically move once from the factory to the place they're put on bricks and never move again. And so these built-in-place, never-move products that are so large really dictate difficulty in transporting them long distances on roads or rail, where you're limited to 14 foot wide and about 12 foot high. They're customized to the site, the climate, particular client's needs, which tends to make them particularly one-off. And they're highly regulated because of the threat to life safety that they propose from fires, from earthquakes, from hurricanes, so that there's typically a lot of local variation because climates are different, natural hazards are different. Is flooding a risk? Is earthquake a risk? Is forest fire a risk? And so on. All of this creates very, very customized and historically built-in-place products. There have been attempts to industrialize. We can talk about that later in this session. The second thing is this industry, again, because it's such a significant investment and people need to be optimistic about the future to make this investment, it's plagued by very severe demand fluctuation. So if the gross domestic product fluctuated like that, the construction volume would fluctuate 5 or 10x, especially in a local or regional market, which is where most of the players in the industry address demand. There are very few international players, except in some specialized niches in the industry, such as perhaps large power plants or natural gas terminals. So what you often end up seeing is a developer with a building half built that abandons it and leaves it just as a skeleton on the skyline. You can see these dotting the landscape all over China. You can see them in the US after the 1989 recession. You saw them again after the 2000 dot-com boom and bust, and you saw them again after 2007. It turns out that specialized local firms can aggregate this fluctuating demand much more effectively than an integrated general contractor trying to do all of these trades could possibly do. Secondly, they're better able to cope with this demand fluctuation because they can do things like maintenance and repair in the off-season. So a plumber who installs plumbing in a new building can come and repair your leaking faucet in a downturn. And many of the specialty contractors also operate maintenance and repair businesses that tend to help them deal with the fluctuation. But they still face demand fluctuation, even with these advantages of being specialized and local. So they typically finance their growth out of retained earnings because nobody will lend them money on any reasonable terms for an extended period, certainly not for working capital. They can borrow against the materials they buy from Home Depot or a distributor and get 90 days credit, and they pay when they're paid by the general contractor, but they don't finance their working capital, typically with bank loans. And they can't easily justify external investments, so you see very few public companies, even in the very large scale construction. Fluor has been public for a number of years, Bechtel is not public, and so on. So the result of all of this is a large but very highly fragmented set of industries. It's really not a single industry, but people tend to think of it that way. It's very mature, which means that its structure is fragmented and it's organized around projects. And we literally, in the US from the last census, have several million small specialized local firms. I call them mom or pop firms. They're not even mom and pop firms. Some of them literally have 0 employees. It's a carpenter with a pickup truck that does house framing. It's a laborer with a wheelbarrow who works on small local sidewalk paving projects. The top 400 firms in the US account for less than half the industry volume. Compare that to automobiles, tires, glass manufacturers, almost any other industry, paper manufacturers, and this is a highly fragmented industry. So what? Because it's so fragmented and you have this multiple set of tiers of construction, we have a client or an architect engineer specifying what should be built. Typically, the client wants something and the architect helps shape the design and the program for the building. They will then hire typically an engineer, or they may be an integrated architectural engineering firm. There are a handful of those in the US. They will assemble the organization that develops the design and the specifications for construction. And then there'll be a general contractor or sometimes a professional fee-based construction manager who will take on the system integration role. General contractor will allocate things like on-site laydown areas, the use of cranes, who comes when, et cetera. And a bank and the client, the architect engineer, the general contractor, process and in some cases withhold the payments. And then the client or the architect engineer can make adjustments to the payment for changes that are legitimate changes that the parties encounter in the construction. So this is, again, a fragmented supply chain, usually many, many more firms than shown on that slide. But it's not just fragmented by specialty, it's also fragmented, as I mentioned, by project phase. You've got pure design firms, you've got pure construction firms, you've got asset management or facility management firms like CBRE who operate and maintain buildings for customers. Some customers or clients do it themselves. And then we're fragmented by discipline. We have architects and multiple kinds of engineers, and then we have 15 or 16 different building trades in construction. Whether it's union or open shop, you tend to see the same kinds of specialization. So how do we coordinate in this industry? I would argue we rely very heavily on standards. Around 1924, we first started getting product standards, the 2x4 wooden studs that we do most of our light construction out of, the 16-inch centers of those studs, which becomes a module for doors and windows and other lighting fixtures and other components. These product standards are now highly organized and routinized in specifications like master format and uniformat, where there are literally hundreds of categories of product components, and the system architecture is worked out very clearly so that the parts will actually fit together and that the standards are mutually exclusive and collectively exhaustive. And that works fine until you try to innovate. The process standards come about in other ways. And then We have found ways to virtually integrate the supply chain to deal with this in some ways, but it's still not very common. So let's look at the different kinds of standards. The process standards are what we call craft administration of production. This term was coined by Stinchcomb. Arthur Stinchcomb was a sociologist who grew up being a carpenter and then became a sociologist. And he wrote this paper that argued that construction uses far less management than other industries. It's very decentralized down to highly skilled craft workers who basically know what they have to do. And because of all of these product standards, you can standardize the training of crafts, and you can basically let them chase each other up through a building with minimal coordination by a general contractor. So it's very light system integration by general contractors in construction compared to what you would see in the airplane industry, what a Boeing or Airbus would try to do, or the auto industry, what a Toyota or GM would do with its supply chain. They also have mature products that have hundreds or thousands of components. A modern airplane has millions of components, but they have very heavy system integrators with dozens or hundreds or thousands of people on a major program, whereas a general contractor will have 4 or 5 people in a trailer supervising a peak on-site workforce of 400 or 500. So again, very, very light system integration. And the result is, again, this subcontractors chasing each other up through a building as long as it's a relatively standard kind of a building. The blueprints say what to build, the craft knows how to build it. The limits of this are, it works fine on a standard building. If you build a small hotel or a suburban office park, all of these standards work just fine. And a general contractor can get by with a very tiny profit margin in the single digits, often the low single digits. When you try to do a non-standard building, all of this breaks down. It breaks down dramatically. So the image on the bottom of the slide shows the Yang and Yamazaki Environment and Energy building in which I work. This building was innovative in the sense of a completely different kind of air conditioning system. It was using night venting to cool the building because we have a desert climate here. And even on a 100-degree Fahrenheit day, the nighttime temperatures will drop into the low 60s or the high 50s. So we can blow cold air through the building and cool it down at night. But this breaks all the product architecture standards. No longer is the window just a window. It's now an actuated window controlled by a central control building control system, which has a logic program developed by a small software contractor, and so on. It has vents in the atria of the building to exhaust the air. And in many ways, it's non-standard. When it's built by a traditional general contractor in the traditional way with their small margins, they don't have enough resources to coordinate all these different trades in a new way, nor do they have enough resources to commission the building in the right way. And so when this building was opened, many aspects of it malfunctioned. It was supposed to be an ultra-green building. It ended up using more energy than a standard building for a significant number of months, almost 2 years before it was properly tuned. A heavier form of coordination similar to what's used in automobiles or aerospace would have been needed to make this kind of building work properly. So to deal with this fragmentation, the lawyers and some principals in the industry have come up with some creative ways to virtually integrate the supply chain. What I mean by that is creating project organizations that have some level of integration between design, construction, and operation. So public-private partnership infrastructure delivery takes the design, construction, testing, and operation of something like a toll road and integrates it into a single, quote, special purpose vehicle, i.e. a project corporation created for the duration of the project, which then hopefully aligns everybody's incentives around minimum life cycle cost of the facility all the way through design, construction, operation, maintenance, and eventually handover. Similarly, a form of contracting called integrated project delivery that comes out of the North Sea oil industry for alliance contracting has been implemented in the US. Initially, actually, after the oil industry, it was used on Heathrow, Terminal 5 in the UK, where all of the main contractors on the project signed a single contract with all of their signatures on the same contract. They agreed to waive liability against each other. And they all get reimbursed all of their direct costs so that it's possible to make changes in construction. And they're all incentivized by a profit pool which reflects the client's ultimate satisfaction with the project. Again, this brings the designers and the builders into the same set of incentives, ideally, and breaks down some of this vertical fragmentation by life cycle phase. So given that we're still building traditionally for more than 90% of construction in the US and probably worldwide, can the digitization of the industry, which has happened since about 2010 at an rapidly increasing rate, can this help with coordination in this fragmented industry and help to bend the productivity curve back up after all these years of low productivity or zero productivity increase? I believe it does. You know, we want to solve this Tower of Babel problem and cope with this fragmentation. So why have computers had so little impact on construction worker productivity when they've drastically improved the productivity of most manufacturing industries, the retail industry, and many others, the logistics industry? The reason is that, first of all, mainframes were too capital intensive for this industry that has to be capital light and can't borrow for working capital. Many computers were too techy or too geeky for most construction firms to use. Some of them used it for their back office. In fact, IBM had a whole line of software for the IBM System 300 mini computers. But for most firms, they still used Excel on PCs, or they just did some of this by hand. So you would think desktops or laptops would help. These were very helpful for CAD and critical path scheduling, but mostly done in the office by engineers, architects, and schedulers. Construction workers can't carry a laptop around. And so none of the computing all the way from mainframes to mini computers to desktop and laptop PCs really impacted the industry. And even the early smartphones, which you would think would now put processing power in the hands of mobile workers, the early ones didn't have enough processing power to render high-resolution drawings. And even more important, there was not enough wireless connectivity to support cloud-based applications and to download significant amounts of data for people walking around a construction site. You could set up a Wi-Fi network on a project, but still, the cellular networks that had to do the long-haul upgrading or uploading of information and downloading were not adequate. So some key technological advances, starting in the early 2010s and then around 2012 when a company called PlanGrid was formed. I'll talk more about them later. We started to see, first of all, the mobile phones that had the capacity almost of a mainframe in your hand. Today's mobile phone in 2019 is actually way more powerful than the early IBM 360 mainframes. And it's much more intuitive with voice and touch interfaces and image capture and so on. And so you now have a mainframe computer in your hand or in your pocket that you can carry around the job site. Secondly, we've got very low cost, almost tending to zero, sensors with MEMS technology that can measure all kinds of things. And we have low cost drones that can capture high resolution image from construction sites. These sensors really make accessible a huge amount of real-time data that before was collected weekly or monthly. You now have instant sensing of what's going on the job site. And moreover, you have these sensors connected via Wi-Fi or Bluetooth on the job, so they don't need to be wired up, so the cost of installing them is much cheaper. Some of them even draw their power just from random RF energy, so they don't even need to have batteries replaced. And so these, together with the broadband cellular networks, once we got past 4G, it was possible to download significant amounts of data to mobile phones, even on cellular networks. You didn't even need to set up a Wi-Fi network on the job site if you had cellular linkage over there. And finally, the third piece of this was just this essentially unlimited cloud storage and cloud processing down to cents per hour of cost in a number of large companies that host huge data centers. So Amazon Web Services was one of the first to offer this capability. And then we see Google and Microsoft and others plowing in. And so the fact that the mobile phone doesn't have to do all the processing, it can just be used as an input and display device with broadband connectivity, has really opened up a huge number of applications that couldn't be done before. So again, this 3D reality capture is a relatively new technology, 2 or 3 years old. Started with 3D cameras that you can now buy for under $200, but then LiDAR and other techniques for gathering very high resolution, very high precision instrumentation, very precise micro-positioning, such as a company called Humatics now provides, both in factories and on construction sites, allows us to capture a huge amount of data with very high precision, timestamp it, organize it, and use it to do interpretation. Robotics has so far had less impact, although we're starting to see robots used in factories for prefabrication. A job site is typically a messy and difficult place in which a robot is challenged to operate, but we are seeing some early construction site robots for things like drywall, for bricklaying, and for extruding essentially 3D printing or additive manufacturing with concrete of facilities. Rapid online payment systems, one of the wonderful things we can do with this digital high-resolution image captures, we can have remote inspections. We can pay subcontractors who borrow at very high interest rates much faster. And so this allows them to bid lower prices, which will have a big impact on productivity. In parallel with all of these technology advances, we've seen some new ideas for business models that exploit all of this technology. And Salesforce.com in about 2006, 2007 switched to agile delivery of apps every 4 months. They'd already been going for a while, and they promoted software as a service. And so the idea that you didn't have to go to Oracle or SAP and pay millions of dollars the way my university did, and then pay tens of millions of dollars to have it customized and maintained when it was supposed to be off-the-shelf software. Instead of which you can use a web browser and access the software on somebody else's computer, again on one of these giant web servers. And the product market fit was wonderful for small mobile salespeople, for Salesforce. And it's also perfect for construction, where companies don't want to be burdened with a capital cost and the long-term obligation of operating their own enterprise software where they can. And so we see literally thousands. There are over 2,000 startups that I'm aware of. In my part-time job now, I'm also working in venture capital, looking at the construction industry. We have seen upwards of 2,000 startups to exploit digital technology for point solutions, such things as processing the liens that subcontractors place on projects until they get paid and then have to release them once they get paid, gathering images on construction projects for a variety of purposes, using analytics in the cloud to derive insights from these solutions. And so what we're seeing is these point source solutions are then connected via application programming interfaces or APIs to the back office enterprise systems, which are also rapidly migrating to the cloud. But even if those are enterprise systems, the cloud-based systems can integrate with those. And so how does all this come together? A great example is a company called PlanGrid that was just acquired by Autodesk for almost $1 billion. It's the first software unicorn that I'm aware of in construction. Almost unicorn, not quite. Tip of the horn is missing. It was bought for $875 million a couple months ago. It was a pioneer in exploiting these technologies. So in 2012, they launched a company. And to deal with the low bandwidth, they had someone from Pixar Animation help them to download the central part of the image and then the parts around it slowly using the available bandwidth, the way you see things like Google Maps working now. The idea was cloud software as a service. Their application was to deliver two-dimensional blueprints in the form of PDF, high-resolution PDF documents onto iPads, so tablets, not phones, because the phone doesn't have enough pixels on it to look at a plan. But the iPad was actually a very convenient way to look at these models. And by the way, you could snap a photograph of something you had a question about. You could dictate a voice memo, and you could attach the the annotated drawing, the photograph, and the voice memo to an email that you send to get a request for information answered in minutes or hours instead of days or weeks. So this was a very clever exploitation of the technology. And all you had to do was buy enough iPads for all the foremen on the project, which you could cover with about 1 month's worth of blueprints on a big hospital project. You may not be aware, but something like a hospital can consume about $20,000 worth of paper drawings every month. So you can buy 40 iPads right there. And then they used a freemium subscription sales model for this cloud-based software where you could initially upload, if I remember correctly, 50 drawings at no cost to try it out. And then if you wanted to use it on a real project with hundreds of drawings, you paid a certain fee. And if the number of drawings went up higher, you paid a higher fee. So it was very easy ramp up, ramp down based on the number of projects you have running and based on how big those projects are. And then the data from the secure cloud delivered wirelessly to smart mobile devices. You just need a password to access the data for your project. And the only software you need is what comes with the iPad, which is Safari or some other web browser you put on there. And then subsequently, this was ported to non-iOS devices, such as Android devices. This company was spectacularly successful. They grew really, really fast. And not only were they delivering blueprints in a new way, these blueprints were always up to date, which is a major problem in construction, because the modification on a drawing might be on its way to you inside a cardboard tube by FedEx, and you're working on yesterday's drawing, building something you're going to have to break out tomorrow when you get the upgrade. Well, with PlanGrid, the drawings are updated every night when the iPads are recharged. And then you've got these simplified, enhanced, automated digital workflows. Instead of a 3-carbon copy speed letter that has your request for information, you've got your email attached to it, photo, voice memo, annotated drawing to make very clear what your question is, and you get an answer back very, very quickly. So this is just one example. There are companies now automating the capture of worker information from mobile phones like Rumbix, which then feeds payroll systems and is used to track productivity and production rates, as well as to keep track of time and materials, extra work, which is paid for on a direct cost basis, and on and on and on. There's a company that takes thousands of pages of PDF files, which are the specifications for the project, and uses natural language processing and this optical character recognition, if need be, and natural language processing to identify all of the specification issues in these thousands of pages that might affect the plumber, if I'm the plumber, on 1 or 2 pages of bullet points. And so I can bid the project very easily, knowing what I'm required to do. And I know what all my requirements are for submittals and for inspections and approvals and so on. And so this is happening very, very fast. So the conclusion of this is that I believe synergistic advances in technology combined with advances in business models are going to enable huge advances in the productivity and effectiveness of construction work in the next decade, even while fragmentation and some demand fluctuation persist. And the reason I'm skeptical that we'll see the fragmentation go away is that attempts to integrate in the past have bumped up against big economic downturns. Going back as far as the 1960s, 50s, and 60s, George Romney, the father of Mitt Romney, was brought in to Housing and Urban Development to run it and to make construction built like cars. And it worked fine as long as the industry was booming. And when the industry turned down, all these companies that had been created to build modular bathrooms, modular kitchens, complete modular homes that had huge amounts of capital invested and loans all went bankrupt. And very few of them survived. One that survived, Clark Pacific Construction, is still building a type of prefabricated concrete structure. They built it based on retained earnings, so they didn't have debt. So when the industry turned down, they could just all take a vacation and come back when it picked up. And so I believe integration has to be done in a very clever way if it's going to be done. It's got to be done by outsourcing the manufacturing to people who can be robust across downturns in the industry. And another strategy some of the more integrated manufacturing companies are using is to straddle multiple industry sectors that historically are countercyclical, such as residential with industrial and commercial. Because when the commercial and industrial markets drop, then typically interest rates go down, housing is more affordable, and the housing market can proceed. And the education sector can build cheaply because there's more competition for their projects. So those things will continue to happen. People will find capital-light ways of doing it, but there'll be fragmentation with us for a long time. But I believe that the technologies that are emerging since 2010 are going to push this digitization really fast, and we'll start to see the results in the next census and the one after that.